Assalamualaikum warahmatullahi wabarakatuh. My name is Kumaira, and today for my technical review presentation, I will be presenting on the topic of swell noise attenuation. So, swell noise attenuation is considered to be the most useful part of noise removal in seismic data processing because swell noise is the most obvious type of noise that can be seen and found in seismic data. So solenoids can be in many forms, from thin lines to large blobs that can be damaging or it may harm the seismic data. So here are the example of swell noise that can in seismic data. So to the left we have the mild swell noise, which as you can see is in the form of thin lines. And this type of swell noise is normally quite easy to remove from the seismic data. However, on the right side, we have the heavy swell noise, which is in the form of thick blocks in the short gathers. So this makes it very hard to remove and thus can damage or harm the seismic data. So as data becomes more and more abundant day by day, the demand for automation and machine learning um, becomes an all-time high. So because of that, many researchers and studies have been conducted focusing on using automation and machine learning to make removal of swell noise or other type of noise removal much more efficient. So before we move on to the paper that I will be reviewing, first we look into the overall research that has been done in regards to swell noise attenuation. I have simplified it into three major sections, which is first is the conventional neural networks. So there have been at least two papers published in regards to that for swell noise attenuation. The secondly is machine learning. And the third part is other methods, such as statistical, non-negative matrix factorization, and UMAP. So all this research is focusing on how to improve the swell noise attenuation and also how to make um, the removal of swell noise much easier. But for this presentation, we will be focusing on machine learning. So this is the paper that we will be reviewing, written by Muhammad Bedri and Maizal Bekra. Uh, the title Application of Machine Learning for Automation of the QC or Quality Control of Noise Filtering Processes in Seismic Data Imaging. So essentially, these researchers are um, figuring out how to use machine learning and what is the uh, perfect algorithm to use to make the QC of noise removal automated. So instead of manually QCing all the data for swell noise removal or other noise removal, instead um, the machine will do it for us based on a set algorithm. So this is the overall data that they have acquired from their experiments. So based on the image, as you can see, between ICA and PCA, PCA yields much better results, much better cross correlation in comparison to ICA. So they have deemed ICA to not be suitable for the noise removal. So they proceeded with PCA. Whereas to decide which type of PCA to use, as you can see in the table, the basic PCA yields the best results while using the least amount of computer power in comparison to whitening and kernel boost. And then once they have decided to use the basic PCA and applied it pre-processing, then they tested different types of algorithms, and based on the table, while there are some algorithms that yield better results, such as random forests, due to the due to how much computer power it takes, they have decided that SVM is the most suitable algorithm to use for the noise removal, for the QC of noise removal. So, what improvements can be made for this research? I think firstly is in regards to neural network technology, since there was an issue in between the computer usage, especially when dealing with large data sets of seismic data. Perhaps they could do more um, efficient use of neural network generation strategy so that they can reduce the memory usage and time consumption. So if they do that, then maybe um, better algorithms can be selected while reducing the computer power. And then secondly is in relation to spatial correlation. Due to the spatial correlation between successive shots have provided useful information related to QC denoising processes. So more exploration or evaluation can be done in regards to this. And with that, that brings to the end of my paper review presentation. Thank you. Assalamualaikum warahmatullahi wabarakatuh.